7.1, nth roots and rational exponents. Your essential question: how do you evaluate nth roots using both radical and rational exponent notation? You are very familiar with radical notation. For example, taking the square root of something. You know the square root sign. What you're not familiar with is rational exponent notation. And they are the same thing, they just look different. So let's get into what a rational exponent is. Well, they are exponents that are expressed as rational numbers. And hopefully you remember what a rational number is. The root of rational is ratio. So these are numbers that are written or can be written as fractions. For example, a to the m over n, notice that that power, that exponent, is written as a fraction, m over n. Now, a is the base, m, which is your numerator, represents the power, what power you're raising it to. N, which is your denominator, represents the root. What root are you taking, like the square root? Rules for rational exponents are similar to the rules of integer exponents, whole numbers, that we learned about in your 6.1 unit. So recall the power of a power property. We're going to use that power of a power property in order to go from, for example, radical notation to different versions of rational exponent notation. In general, we have the fact that something that looks like this, which is in radical notation, right? It's got that radical sign, can equal something that looks like this, which is in rational exponent notation. And you have to be able to go back and forth between these two different types of notation for various reasons. So let's start with the square root of a. The square root of a is actually, or can be written using rational exponent notation by writing a to the 1/2 power, right? Because we are taking the square root, so that is your denominator. Denominator is your root in blue here, okay? And your numerator is the power. Well, after I take the square root of a, I'm not raising it to any other power. However, if you look at the next one, once I take the 4th root of a, then I'm raising it to the 3rd power. So my root here is 4. That's going to go in the denominator of that rational exponent. So I'd have a raised to some exponent that's a fraction. 4 is going to be my denominator because it's the root. And then the power that I'm raising it to, that's my numerator. All right, so we just took the radical notation and we went to rational exponent notation. Now let's work backwards. Let's take the rational exponent notation and let's turn that into radical notation. Well, again, the denominator of my rational exponent is actually my root. So I know that I'm taking the 8th root of a, and then I'm raising it to a power, and the number in my numerator is my power. So now this gets raised to the 7th power. Okay, I'm going to do one more here for you. Do you guys remember what happens when you have negative exponents? In order to make that exponent positive, you need to take the reciprocal of the base. So you actually have to flip the base. So what I end up with here is 1 over a raised to the 7/8 power. Or in other words, now, the number that's going to go under my radical, my radicand, is actually going to be 1 over a. I am taking the 8th root because that's my denominator, and then I'm raising that to the 7th power. I could also write this another way. Remember your power of a quotient where you could give the power to the numerator and the denominator? So I could actually write this as 1 to the 7/8 over a to the 7/8. Well, 1 to any power is still just going to be 1. So I would have 1 in the numerator. Now in the denominator, that's where I will actually rewrite this in radical notation by taking the 8th root of a and then raising that to the 7th power. Those are equivalent. You can write it either way. And it becomes tricky as you're trying to figure out, well, what's the right way to write this? Both of those are correct. Let's come back up to this box and show you all the different ways that you can write things. So your first bullet is just saying, hey, radical notation is the same as rational exponent notation. Or you could write it as like a to the 1 over n, which gives you the nth root of a, and raise that to the m power. I would even argue that you could write it as a to the m raised to the 1 over nth power. That's still going to give you a to the m over n, or the nth root of a to the mth power. The second bullet talks about your negative exponent and how you need to make it positive or else it's not completely simplified. And that's all the different ways that you can write, just like we did, a to the negative 7/8. So in this next table, I tried to show you the different comparisons between radical notation and rational notation. Radical notation you're very familiar with. That's where you always use that radical sign. And so every column here, I did a different type of example. So if I have 2 to the 3rd power equaling 8, then it would make sense that the 3rd root of 8 would equal 2. Because what number times itself 3 times gives you 8? 2. Well, you can see below how you would see that in rational notation. Instead of saying the cube root of 8 using a radical symbol, you're now going to use 8 to the 1/3 power, and that also equals 2. In the next column, you have negative 2 being raised to the 3rd power, equaling negative 8. So again, in radical notation, you could make an equivalent statement that the cube root of negative 8 equals negative 2. Or you can use rational notation to say the exact same thing, that negative 8 raised to the 1/3 power, which really is the cube root of negative 8, equals negative 2. All right, so these two dealt with odd roots. Now I'm going to move over and deal with even roots. So the square root, which hopefully you're very familiar with, we know that if 4 squared equals 16, then I can take the square root of 16 to get 4. Well, down below now we wrote it in rational exponent notation. What if you have negative 4 being squared? Well, you still get positive 16, which tells you then that if you took the square root of 16, you could also get negative 4, right? Or writing it in rational exponent notation, 16 to the 1/2 power is negative 4. This is going to get a little bit confusing for us. Okay, in general, if we say the square root of 16 equals what, you're going to say it equals 4. However, if you have an equation such as x squared equals 16, then there are 2 answers to this equation. There are 2 numbers in this world that you can square to get 16, right? One of them happens to be 4, because if I square 4, I get 16. The other one happens to be negative 4, because if I square negative 4, I get 16. Therefore, the answer to this equation is actually x equals positive or negative 4. So if you're solving an equation, then you're going to have 2 answers, usually, if you're taking the even root. Another thing I should probably remind you of is that squaring negative 4 is not the same as squaring negative 4. So this first one is really negative 4 times negative 4. Well, that's going to give you 16. This second one is really negative 1 times 4 times 4. And that's actually going to give you negative 16. Which brings us to another reminder. I'm going to go right down here to this very last bullet point. If n is even, so if you're taking the nth root, okay, so, and it's even, so the square root, the fourth root, the sixth root, the eighth root, and a is less than 0, in other words, a is a negative number, then a has no real nth roots. No real nth roots. It does have complex roots. For example, if I'm taking the square root of negative 25, well, remember, you have to use that imaginary unit, right? So this is really the square root of negative 1 times the square root of 25. And the square root of negative 1 is I. The square root of 25 is 5. Which leaves me with a complex root. Or if I had written this as an equation, let's say, for example, x squared equals negative 25. Well, you would need to take the square root of both sides, in which case x would give you a positive or negative 5i. In that case, you'll have 2 complex roots, but no real roots. Okay. Other things in this nth roots box. If n is odd, then a has 1 real nth root. So, for example, when I took the cube root of 8, I only got 2. And when I took the cube root of negative 8, I only got negative 2. However, if you're dealing with even roots, you could potentially have both the positive and the negative answer. Just like here, when I had x squared equals 16, I had 2 potential answers. Okay, so we'll leave it as 2 potential answers when you're solving an equation. And then the third bullet here is actually quite simple. So if n is even or n is odd, and a is equal to 0, well, any root of 0 is equal to 0. Let's think about it. The square root of 0, well, what number times itself gives you 0? 0. How about the cube root of 0? What number times itself 3 times will give you 0? 0. So no matter what the root is, you're going to end up with 0. All right, let's find the indicated nth roots of a. For our first example, we're going to find the nth roots, and we're going to find the indicated nth root of a. So the question here is, if I were to raise some number to the third power, I would get negative 125. So what do I have to raise to the third power to get negative 125? What can x equal? Five can go into 125. Let's see, 25 times. And then 25 has the factors 5 and 5. So in fact, 125 is 5 cubed. So could I also cube negative 5 and get negative 125? That actually checks out. So in this case, there's only going to be one number that I can cube to get negative 125. And that is, in fact, negative 5. So I know that x has to equal negative 5. All right, let's do the same thing with b. So in this case, I am raising something to the fourth power, and I am getting 16. So let's think about, is there anything times itself 4 times that'll give me 16? Well, let's see. 16 is 4 times 4. And then each of those 4s has factors of 2. So in fact, 16 is 2 to the fourth power. So I can say to myself then, if I raise 2 to the 4th power, I get 16. Is there any other number that I can raise to the 4th power to get 16? And in fact, there is, -2. So we know that x can equal positive or -2. So if you have an even root, you can potentially have 2 answers. If you have an odd root, you're just going to end up with 1 answer. All right, now we're just going to evaluate expressions. So we're not going to worry about positive or negative because we're not going to have equations. We're just going to go straight forward. So we have to understand what's happening here. My denominator for a is 2. That means I am taking the square root of 2. I'm going to show you a couple ways of doing this. And then I'm going to raise that to the 5th power. Okay, well, the square root of 16 is 4. And then I'm going to raise that to the 5th power. Ooh, that's tricky. Well, let's see here. I know that 4 times 4 is 16. So another 4 times 4 would also give me 16. I know that 16 times 16 is 256. And then I'll go ahead and multiply that again by 4. $1,024. You can also use a calculator. Now, that is not the only way to go about evaluating this. There's actually another way that I prefer. And I'm going to take you back to 6.1, and I'm going to refresh your memory about the product of powers property, where, for example, if I had a to the m power times a to the n power, then I ended up with a to the m plus n. I'm going to do that to help me simplify this. So I know that if I have bases that are the same, such as 16, I can multiply those bases means I'm going to add the exponents. So let me see how many wholes I can get out of 5 halves. How many times does 2 go into 5? It goes in 2 times. So I can rewrite this as 16 to the 4 halves times, and then 16 to what power will get me those 5 halves? That's right, 1 half. All right, well, 16 to the 4 halves is 16 squared, I'm just simplifying, times 16 to the 1 half. Well, 16 squared, as we learned back there, was 256. And the square root of 16, which is 16 to the 1 half, is 4. And I'm right back to my 1,024. Okay, and we're going to do a lot more of that in our next section in 7.2. All right, let's try this next one. 64 to the -2/3. First of all, we have a problem. We have a negative exponent, and we need to make that negative exponent positive. So I need to do the reciprocal of the base. So I'm going to go 1 over 64. And then I'm going to raise that to the 2/3 power. Then I'm going to use the power of a quotient property to give that power of 2/3 to both the numerator and the denominator. Well, 1 to the 2/3 power is just going to be 1. On the denominator now, I'm going to have 64 to the 2/3. And while you're getting used to this, it doesn't hurt to rewrite this in radical notation. So I'll have 1 over the cube root of 64, and then I can square that. All right, well, what is the cube root of 64? So now we got to go back to 64 and figure out some powers or some factors. So now we need to go back to 64 and figure out some factors of 64. Well, I know that I've got 8 and 8, which breaks down to 4 times 2 and 4 times 2. Notice these two 2's become a 4. So I actually have 3 4's. So 64 is 4 cubed. Maybe you already knew that. All right, so then I'll have 1 over the cube root of 64 will be 4, and then I'll have to square that. Or in other words, 1 over 16. Or I should circle my answer back here. All right, and let's do C. So again, I notice that I have a negative exponent. So the first thing I'm going to do is do the reciprocal of the base to get a positive exponent. So 64 over 25, and all of that gets raised to the 1/2 power. Again, I'm going to do the power of a quotient property, so I'm going to give that power to both numerator and denominator. That power is 1/2, which means I'm really taking the square root of numerator and denominator. It'll be really easy if you can go back and forth between radical and rational exponent notation. So this becomes 8/5. You can leave it like that, or you can turn it into a mixed number. This is just fine for me for now. All right, so using a graphing calculator to approximate a root, this is going to become a really important skill. So you're not going to use a radical in your calculator. What you're going to do instead is you're going to put it into rational exponent notation. And to do that, you're going to need to use your caret button. So let's do 5 to the 3/4 power in our calculator. You're going to hit 5. You're going to look for your caret button, which is just underneath the clear button. It's in the row beneath the clear button. It's really important that when you put fractions as your exponent in your calculator, you use parentheses. So this is going to be 3 divided by 4 in parentheses. Now press enter, and I get about 3.3437. Or how about I'll just go 3.344 to the nearest thousandth. Okay, so practice using your calculators with those.